Okay, so inheritance. This is another object-oriented concept. Inheritance occurs when a class inherits behavior from another class. The class that is inheriting the behavior is called the subclass, and the class it inherits from is called the superclass. We use inheritance as a way to extract common behaviors from classes that share that behavior and move it to a superclass, so to keep our code dry. So a lot of times, like I explained yesterday, I think it was yesterday, but I get the days mixed up, I think it was yesterday, a lot of times what we need to represent are objects that are similar to each other. They have similar attributes, similar behaviors. They're not exactly the same. So I gave the example of animals and pets, and then specific kinds of pets, and how all animals have certain things in common, certain attributes and behaviors in common, and then there are differences between particular categories of animals and types of animals. And so the way that we would model those sorts of relationships where we have objects that share behaviors and share attributes with some differences is using inheritance, when we used an object-oriented paradigm to do our programming. So let's have a look at an example. So here's the animal example. So if we say that all animals make noise, I think they do, probably, mostly, all make noise. Maybe we can't hear all the noises they make, but I think they probably all make noise. Then we could define a common behavior of an animal, like speak. And maybe by default, our animals are people, apparently. And by default, they say hello. And we could, for example, you can tell the person who wrote these slides has a dog bias. We could, for example, subclass the animal class to define a particular kind of animal called a good dog. And we could define another subclass of the animal class called cat. And
so good dog and cat are the subclass?
They're subclasses
of animal.
Of animal.
Yeah.
And the syntax in Ruby to indicate that is what we see here. So we say class name, and if we want it to subclass another class or inherit from another class, we use the less than symbol. So it's like it's taking behaviors and attributes from the superclass. Is a way that you can kind of think about it. So by doing this, we can take advantage of common behaviors and attributes in the superclass. So if dogs and cats also speak, and they happen to also be in this really, really weird, bizarre universe where they say hello, they speak English, then we can just define these classes, and when we instantiate good dog or cat, we can call the speak method. The speak method is available to them. So any methods and attributes that are available in a superclass are also available in a subclass. Okay? All right. I think I covered all of this. Now, sometimes we want to have the same behaviors, but those behaviors might be slightly different between our superclass and our subclass. So in this example, we have speak, and while we're assuming that most of the instances of our superclass are humans, I'm assuming because speak says hello, our subclass, good dog, does have a speak behavior, so we want a speak method, but it should behave slightly differently. So in that case, we can override any method that's in the superclass and replace the implementation of that method, the block of code inside of that method, with an implementation specific to our subclass. So if we override the speak method in good dog and it returns wolf, then when we instantiate good dog, that we call speak, on that instantiation, it will say wolf. Okay? So this is useful when we want to model the same behaviors between a superclass and a subclass, but we want to make slight changes maybe, or maybe sometimes big changes to the way that that behavior is implemented. Now, what happens when this code is executed? Say we instantiated the good dog class, and then we call speak on that instantiation. So we say Sparky equals good dog.new. Sparky is an instance of the good dog class. When we call a method on any object, what not just Ruby but other object-oriented programming languages will do is first it looks in the class definition for this class that we've instantiated. So it looks in good dog first, and it says, is there a method called speak there? And if there is, it calls that one. It executes that one. And if it's not, in the case of cat, when we say pause.speak, we look in the cat class first, and we say, is there an implementation of a speak method? And there isn't. Then we go to the one level up to its superclass, and we say, animal, is there an instance of a speak method, an implementation of a speak method in animal? And if there is, we execute that one. And if there wasn't one in animal, then we would look at animal superclass, all the way up to objects, and we would look for this method all the way up, from the bottom to the top. And if we don't find it, we get a no method error. But if we find it anywhere along that path, it will execute that one. Okay? Yes, Aiden?
So using this like syntax, are you able to nest subclasses and subclasses?
Are you able to nest subclasses?
Like if you use make another subclass within say good dog, would that work? If you did like
So you could
name of
extend
it?
good dog. So
Yeah.
you could inherit from good dog, yes. So outside of this class definition, we could define another class. So maybe we would have a middle class called dog that extends animal, and then we have another class called good dog that extends dog. Yeah? And then, yes, so you can do that as much as you want. Okay? So when we, in the example we did earlier today and yesterday, when we overrode the method 2s to string in our classes, right? We were taking advantage of this model of inheritance to provide our own implementation of 2s instead of using the one that's up the chain in object. Okay? So we don't have to define every method that's defined in our superclasses and our subclasses. We only have to define the ones where we want the behavior to be different than what it is in the superclass. Okay? So Ruby and other languages, not just Ruby, have a keyword called super. And what super does is it allows us to call methods up the chain, up the inheritance chain. And so sometimes what we want is we want the behavior of the superclass, but we want to add something else to it. So we want the superclass method to do whatever it does, but in addition to that, we want to do something else. In that case, we can call super first and say, do your thing, and then I'm going to do some other stuff. Okay? So we don't have to know how that method's implemented. I mean, we do have to know. For calling super, you should know what it does. But we don't have to have the code there. We can just call super, and that's going to call the method in the superclass. And then we can add some code after that and do some additional stuff. if our method takes arguments or parameters, then we'd want to pass those parameters up to the super method, right? And allow that super method to execute, and then do our thing. But it's also possible to override a method in your subclass, and the method you're overriding doesn't take arguments, and your subclass method does take arguments. That's okay. All right.
Well, can you do that if you just want to recall information from it?
So if you want to execute the method of the superclass, so we use this form of calling super inside of our subclass method when we want the superclass method to do whatever it does. So here's an example where we have, in our superclass, we have an initialize method where we set the name. So we take in a name as a parameter to initialize, and then we set an instance variable called name to the value that's passed in. And our subclass good dog, maybe we take a name and a color or an age or whatever. And so instead of doing this and keeping up with this instance variable in our subclass, we can just call super with name. That will take care of initializing the name instance variable for us. And then we can add any other initialization we want for this particular subclass. So that's a pretty common use of that structure where we call super and initialize with some set of parameters that are passed in. And then we have some additional parameters associated with the subclass that we initialize in the subclass. So in this way, we allow the superclass to take care of and maintain and keep up with all the things that are common, right? All of the attributes and behaviors that are common across these different object types, all of that lives in the superclass. And then we only have to deal with what's different in our subclasses. And this means we get rid of a lot of repeated code, right? Because if we have a dog and we have a cat, there are going to be some things that are similar between those things. And these are trivial examples. When we talk about, maybe we talk about an application where we have different types of users. So we have maybe like a customer, and we have an admin user, or maybe in an HR system we have managers, and we have team members, and we have VP and CEO. All of those people are going to have things in common, aren't they? Like name and address and employee ID. There are going to be a bunch of attributes that are common between those object types, but they're very different objects. They all have some unique properties, and they will have some unique behaviors, right? So a manager is going to have behaviors like attending a manager meeting or hiring people or things like that that a team member may not have, right? And a team member is going to have behaviors that maybe like checking in code that a manager doesn't have. And so we can represent all of the common things that these different objects do, these different type of people do in a superclass, instead of having to repeat that code in every object representation, every class that we have to define for these different kinds of people. And then that makes our code drier and cleaner and easier to maintain, easier to test, easier to understand. So let's try this because it says, I'm just going to paste this into VS Code. So we have an animal class with a name accessor, and in the animal class we initialize our name instance variable to what's passed in, And then in our good dog subclass, we also have a color attribute. And right now we're calling super, which sets the name. And then we're setting color. And if we run this code, you have to save it first. Then we can see if we print out that object. This is where I want to override 2s. But anyway, we can see that there's a name and a color instance variable set for this good dog object that's instantiated. Now, what do you think is going to happen if we comment out the call to super and just don't do anything with name? Name's not going to initialize, is it? Save it. So we just don't get name initialized. So the only way, if we override a method,
how would you get, if you were to uncomment the super, how would you get it to show not whatever that is, x, 0x?
to show it a different way, you mean? Like to not get that display?
Yeah.
The same way that we have been doing with, so if we did it in good dog,
Yeah.
we could define a 2s
Mm-hmm.
that did a puts name like we did earlier, color
You want to uncomment that?
Interesting. So, first of all, I did it again. That wasn't the problem though. So P, which is print, does not call to S.
Right.
We'd have to find out what P calls.
P calls the object type.
Object type?
Like, well, that tells you the type of thing.
So if we, what did I forget to do? Oh, yes. So if I change it to puts, then we get that behavior. But see, when we did P and puts without our 2s, the output was the same. Watch. Oh, it's different. So the P gets the instance information. Dot inspect. P calls dot inspect.
Yeah.
Okay.
So if you rewrote
Inputs calls to S. So if we rewrote inspect.
it should.
Yeah.
What? If you rewrite inspect.
Yeah.
What's inspect?
Inspect is a method that we inherit from objects. And of course, every class is a subclass of object. So we're just overriding methods here.
Where's object?
Object is the parent of everybody. It's the big daddy. There we go. Okay, did everybody follow what I did there? No?
I saw what you did, I didn't understand.
Okay, that's all right. Okay, so we had talked a couple of times already about how if we want to override what puts gives us when we puts an object, by default, puts calls to s. And by default, in object, 2s prints out a string in the format that we saw. So it prints out the angle brackets, can't remember now, with the object ID and the class name. Hold on, I'll find it. So by default, so in my code here, I'm calling puts first on the object, and then I'm calling p on the object, which is shorthand for print. Okay, so by default, 2s, which is called by puts, prints out hash less than class name colon object ID greater than. By default, the implementation of 2s in the object class, that's what it returns. Okay? Now, in classes like string, number, the basic kind of data types, array, hash, they have overridden 2s to return something that's more consumable. Yeah. But in classes we define, they inherit directly from objects. So we're just getting the default 2s, which prints it out like this. Similarly, print, or p, calls inspect. The default inspect that comes in objects, and I think most classes, I think a lot of classes don't override inspect, but some of them might. The default output for inspect looks like this. So you get the first part, it looks a lot like what you get from 2s, plus you get any instance variables that are defined and set. That's the default output for inspect. So if we want to use print to print our object, and we want it to print something other than that, then we need to override inspect to return the string the way we want to see it. So by overriding both inspect and 2s, we can determine what gets printed when we call puts or print on our object. Okay? And we're taking advantage of the same property of inheritance. It's exactly the same thing. All right? So every object has the behavior that it can be printed or can be put. Right? Every object has a toString behavior and an inspect behavior. But we may want that behavior to be slightly different for a particular subclass of objects. So if I don't override initialize, let's go back to what this was about, which was, and I'll comment this, I'll put this back. So what we had looked at was, if we override initialize in our subclass, and we don't call super, then we don't get the initialization of name. All right? If we didn't override initialize, we'd be okay. Name would get initialized. But as soon as you override a method, what happens when you execute the code? Just like I talked about a minute ago.
It goes up to the object.
That's right. That's right. So the first place it's going to look is, in the class definition for this object, is there a method called this? And if there is, I'm executing that one. And if there's not, I'm executing the one in its parent. And if its parent doesn't have one, I'm going to its parent. And if I go all the way up to object and I don't find this method, no method error. Okay? So that's why if I don't override initialize, name's okay. But if I do override initialize, then I either need to initialize name myself or call super. And it would be silly to initialize name myself. It would make more sense to call super. Okay? Yeah, Aiden?
So, you've got name parentheses initializing the subclass. Do you need that there to do super?
Yeah, you do. Yes, because super If we look at the super method, it takes a parameter,
Yep.
and that's a required parameter.
I was just thinking that it would actually import super.
No. No. So if I override initialize, I have to explicitly pass that parameter to the super method.
I see. Yeah, that's how it works.
Mm-hmm.
And
Yeah, Mark.
you're overriding names in Good Dog because you want the name to be transferable to either animal, the cat or the dog.
I just want
You
name to
don't
be
want to
set.
have.
I-
You don't want to have cat name, dog name.
No.
You just want to
I
have
just
the
have a
name,
name.
and you just want it to whatever the name is equal to. You want the
I want that to be set.
inherit it or the dog to
Yep.
inherit it.
Yep.
Name.
What's
So
your
my
question?
question is, supposedly in good dog, right? We have the master, that 2s. If we
Yes.
put that 2s to the parent, the super class,
Yes.
and we do puts with good dog inside that class, or we override the 2s in the child class.
No. So, no. So again, the way it's going to work is we start from the bottom. So if we have a 2s in good dog, that's the one that gets executed. If we don't have a 2s in good dog, but we have one in animal, that's the one that gets executed. If we have one in both places, the one in good dog gets executed. The one in animal
Because my
gets
question
ignored.
is, if there's not one in good dog, but there's one in its
No, the one in
class.
animal will get ignored unless we call super. So for example, we could
So
say,
if you had a cat as well,
mm-hmm,
and it was inheriting from animal, wouldn't you put them, as Mark is saying, in the animal rather than doing it twice in each?
we could do this, okay? Because in the superclass we only know name. And then in the subclass we could say, so in the superclass we return name, colon name. In the subclass, we call super. That returns back that first part of the string, and we concatenate it with the second part of the string.
What if we don't have this 2s function? So what, there's only print the names in this case?
In the case that we instantiate a dog,
So
a
if we
good dog,
comment this one,
yes,
and we do put
yes, you only get the name.
so it just overrides essentially what the parent class.
That's right. So if we define it in the subclass, it's always going to override anything that's in a superclass. But we can still get the superclass to do work for us by calling super. Okay? So if we want the superclass to be responsible for printing its attributes, and each subclass is responsible for appending its attributes onto what the superclass returns, then this is the way we would do it.
I like the way that looks.
Hmm?
I like the way that looks. Much more.
You like this?
Yeah.
Yeah. And this makes sense, right? Because again, we're keeping that model where the superclass is responsible for the attributes it controls, right? The common attributes. And the subclass is responsible only for the attributes that are unique to the subclass. So we carry that through with the 2s method as well. Okay? All right, so we're going to pause here, guys.